Netherlands. And we like both Germany and we like England. So our Fredington go to Lorentz. You might know Lorentz, famous scientist in the Netherlands. And say, you have to go tell Einstein that he was right. And so Lorentz sends a telegram to Einstein saying, here is really boring. Here's the picture of the stars. Here's the information of the two stars. Not congratulations. No, just boring, like a scientist. There, you were right. And what happened? For the first time in history, a physicist was front page news. America loved it, England loved it. Front page, Albert Einstein and his discovery of space-time. It was really big. He was flown to America straight away, or not straight away, but soon after. And yeah, it was big news in physics. So good. Then Einstein, his model seemed right, so he was in a position where he had this mathematical model, and he can put in the universe. Yeah? So he put in the universe to calculate what is happening to the universe. And what did this model show? This model showed that our universe is expanding. It's getting bigger. That was the first time. So, not the space in between, but just every galaxy was moving away from other galaxies. All galaxies were moving away from each other. Yeah? And what does this mean? Back to this story. If the universe is now expanding, what happened before? Contraction. If we go back in time, it gets smaller, 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 smaller. Big Bang. There must have been a start. And Einstein said no. Einstein didn't want to believe it. The start of the universe? No. And so he discredited himself. Later he says it was his biggest blunder. Einstein himself said this was his biggest blunder. He said no, this cannot be. There cannot be one star. Right, but then, years later, there was a scientist, Edwin Hubble. Yeah? And Edwin Hubble had a telescope, and he looked at the stars far away. Yeah? Galaxies. And what did he see? He saw that the universe was expanding. Now, how can you see that the universe? How can you see from here with a telescope? Oh, it's moving away. There's a special way to do it. Anyone knows? How can you see that a star far away is moving away?
Light.
Right? I looked for one word. It's an effect. Doppler effect. You know Doppler effect?
Yes.
Yes? Who said yes? You said yes. Can you explain quickly Doppler effect? Can you explain? Yeah? Do you know? Yeah? Please explain. Please explain in the polling Doppler effect. Okay. Does everyone know you know Doppler effect? Yeah, the change of frequency. So you see the hybrid. Everybody knows, yeah? Okay, we don't need to explain. You're lucky. You don't have to explain, it's fine, everybody knows. So stars that go away from us are red. Show red light. Red light. Lower frequency. Yes, they're moving away. Lower frequency to us. Stars that are even further away, more red. More red. They are further away and they are going at faster speed. So he showed that the further away they are, the more red they are, the faster they go away. So expansion. Good. But only we are not expanding. We are not the Earth is expanding, not the whole universe. You know, only the space in between. So the stars stay the same size, but move away. Good. Alright. But Big Bang was not a popular theory. Who came up with the term Big Bang? It sounds silly, doesn't it? Sounds like children. Big Bang. Well, Big Bang. It was people who were the opposition of the theory. People who said, you believe in Big Bang, you are crazy. You know? And it took a long time. It took till Arnold Penzias and Robert Wilson in the 1960s to have another proof for this theory. They were playing with radio signal, listening, yeah, into space. And there was a noise. There was a tiny little noise in the radio signal, and they couldn't get it away. There was pigeons in the radio, so they ran the pigeons. And dust, you know. They cleaned their machine. The noise was still there. The noise stayed. So then they were in the pub, having a beer, talking to some people from Princeton, big university, yeah. And they were astronomers. And those people, the people from Princeton said, you have done exactly what we wanted to do. You have listened to the background noise of the universe. You know, noise coming from the background of the universe. And 10 years later, these two get Nobel Prize. Yeah, because they just listen to the noise from the background. Okay. The sound, what did they hear? The sound they listened to. The noise that they heard was in the first book. About 300 and maybe about here, 380 pages. Yeah? There was light escaping from the universe. Before that, the universe was too dense, nothing escaped. It's like the sun. You know sunlight to go to Earth? How long does it take? 8 minutes. Yeah. But there's also light created in the center of the sun. You know how long it takes light from the center of the sun to go to the outside of the sun? 100,000 years. Because the sun is so heavy, the light's trying to get away, but it's curved, eh? It's difficult to get away. Okay. So the same thing. The first part of the first book, no light escaped. After that, some light escaped, and that's what we see. That's what we see in the background. The light, first, in the beginning, the light that escaped was really hot, energetic, and expands. And right now, the surface is 2.7 degrees Kelvin, minus 270 degrees Celsius, yeah? 2.7 degrees above absolute zero. You know absolute zero? Yeah? Good. Good. So the light has become radio signal. That's what we can listen to with the radio. Yeah. Now we use satellites. Yeah. Robert Penzias used the radio dishes, but we use satellites for really precision listening. And you know we look at stars with satellites, and we see Alpha Centauri or Proxima Centauri, and it's how many light years away? Did I say? 4? Yeah. So it's light from 4 years old. Yeah. 4.3. Yeah. And across if you look across the Milky Way, light from 100,000 years old. But if you look at the background noise, how old is the light? The light we see is 13.7 billion years old, minus 380,000. And I could only print in black and white, so it's not very nice. But if we put all the light together, we get a baby photo. This is a baby photo of the universe. This is the first light. Yeah. This is a picture, and it's normally you see it in green and blue and a little bit of red. Yeah. You may have seen it before. Okay. Do I have time? Yeah, a few minutes. Okay. So now, because of Einstein, we know there was a start. We have seen the start. this matter? Is important to us?
Yeah.
Yeah? Why? Why is it important? I don't understand, but not yet. That's good enough. Creation, result. We are here. Fine. No. It is important. And in here is how this picture, yes, it's a bit of a lumpy soup. A lot of matter flows by, and then slowly the matter turns to clouds. We get clouds, and from the clouds we get the first stars. And the first stars, very rough, explosions everywhere. You know, a very rough world to live in. Explosions, and the stars start to group together in strings. Slowly, the strings become galaxies, and the galaxies form, and you get several galaxies. All in the twists, like our galaxy. But it's very important for our own creation. What are we made of? What's the very smallest? Atoms. Yeah? We're all made out of atoms. Did all atoms exist here? All the beautiful atoms that we are made of? What are very important atoms? Oxygen, yeah? Nitrogen, carbon, very important all for life on Earth. How were these atoms created? These atoms are created in supernovas. You know supernovas? The explosions, heavy explosions in stars that expand and crash back together. These are nuclear reactions. You know, they change the nucleus of one particle. They come together and they create new atoms. So slowly, all the atoms are created. Here's one thought. If I look at the atoms in my hair, in my nail, whatever, you know, any atom, how many organisms do you think your atom has been, average? Your atom, before you were born, must probably be about 3 lives before you, every atom, somewhere else. This atom was an elephant, this atom was a dinosaur. Probably one atom, one bacteria, then another bacteria, then another bacteria, then you. Not a dinosaur, probably not. You know, reincarnation from a bacteria, probably. But you know, they're very important for life. Alright. How many in the Milky Way in our Milky Way we get supernovas? Yeah? We get one approximately every few centuries. Every few centuries. When this happens in our Milky Way, when a supernova goes off, we can see it in the sky in daylight. One supernova gives the same light as all the other stars together. Yeah? That's that much energy. The last one was in 1604, just over 400 years ago. There was a scientist, you may know him, Kepler. Kepler, have you heard of Kepler? Elliptical orbits. He recorded it. He saw it. He written it down, and he written about it. So that's why we know. But this is it's been very important for the creation of atoms. What does this mean? We are all made of stars. Yeah? We are made of stars. We are the universe. We are all one. Yeah. So this is the history. This is first with the orientation. Where are we in our universe? And then we had the history, time. There's things. We can talk about 2 little things we don't know. You have heard about dark matter and energy? Yeah, this is just extra to lesson. Lesson is finished, but extra. There's things we don't know as well as scientists. We know that if we use the equations, we miss a lot of matter. We only know 4%. What we see, the stars, everything we observe, is 4% of the universe. There is, biggest part is something called dark energy. It keeps keeps the galaxies together. It's a skeleton of the galaxy. Yeah, we know it's there, we don't know what it is. This is why you study, some of you will maybe go into physics, some into chemistry, you know, you're all scientists. If you go into physics, it could be likely that you study this, and in your lifetime that you find out what this dark matter is, what this dark energy is. We don't know what it is, but we know it's there, and we're going to look for it. That's our next mission. Yeah. It was also, this dark energy was actually predicted by Einstein. Einstein said, the universe cannot be expanding. You know, he didn't want to believe it. But if it is, there's this energy. He predicted it. But he said, no, it can't be expanding. So even when he said, he made his biggest blunder, yeah? He said, not true. What I did is not true. It works, but it's not true. But even in this blunder, he predicted that there was this energy already. He was brilliant. Brilliant guy. And then there's one other question. What was before? Hey. You know, very start. Very start. Hold that again. Hold it up. That was slightly bigger. Slightly bigger was the actual size of our universe. Yeah? This was here. This is not scale model. That's the size of our universe at the start. Everything, all the stars, everything in there. In there. So, what's up? What was before? We don't know. Maybe there's more universe. Maybe there's 20 of them next to each other. You know? There's many theories about what's outside our universe. There's only one problem. We can never look outside our universe. We will never find out. We may find out what is dark energy, dark matter, but we will never find out what is outside our universe. Yeah, this was the lecture. If you have any questions, yes, one question. Yeah?
Firstly, since people used to think about that we have got the sun, Earth is the center, and after that they started to think about the planets, and then after solar system, another system, that makes the galaxy, and multi-galaxy. And nowadays scientists have raised the question about the multiverse. It is possible. Multiverse, universe, another universe, another. That creates another group of where we live, area of the
where we live. So maybe contract new universe. Or
I just want to ask you that there is possible of multiverse.
Yeah. Multi-universe. That's one of the theories. Like I say, you know, that was the universe. Maybe there's other universe, expanding, contracting. There's many theories. But these are difficult to explain because we cannot look outside our own universe. So maybe we find ways, maybe we find loopholes, I don't know, to explain them. But yeah, of course, yeah, it's possible. Yes. I don't know, I'm not a professor yet. I'm not professor of the universe. Professor universe. Yeah, but it's good study. Good study. Awesome. All right. Thank you. Thank you guys. Thank you guys. For you. Maybe watch before we do. Keep the pepper. Thank you. 15. Start soon.
Mother,